This is a presentation about CatViz, a tool for exploring high-dimensional datasets. It's a joint work with Lefteris Koustofios, Gordon Woodhull, and Jim Kluzowski. This work is motivated by the abundance of white datasets. There are a number of reasons for such datasets to arise in practice. First, the dataset might have many features originally. A second reason is that the dataset is obtained by joining many data sources together. Another case where such white datasets arise is model inspection or exploration. For example, you might be looking at the intermediate layer outputs of a neural network, or you could be looking at the outputs of individual classifiers in an ensemble or boosted model. Understanding white datasets can be difficult and time-consuming. Very often one would be dealing with cryptic column names. And having too many columns does not help with fitting the data into the screen. When columns are not in a meaningful order, exploring the relationships between them becomes even more difficult. Clearly, there is quadratic complexity of probing pairwise relationships between the columns. Our visualization in CatViz is based on a number of abstractions. We use weighted graphs to represent the relationships between the columns. The strength of the relationship can be measured in a number of ways, including mutual information, variable importance, and so on. The nodes in the graph are grouped into clusters of highly related columns. We believe that this could help obtaining a semantic ordering of the columns. Linked histograms are provided in order to facilitate the exploration of data values and distributions, and also will provide a clickable interface to explore the relationships between two or more columns. Another piece of visualization in CatViz is the decision trees. These decision trees are computed for predicting every variable in the dataset from all the other variables. These trees minimize manual exploration labor because they make clear higher order relationships, and also they reveal coding-recoding relationships or other functional relationships between the columns. In terms of software components, we use a number of JavaScript libraries. We use dc.js for creating charts of multidimensional datasets. It supports many styles of charts, and also it allows linking those charts. Another component is dc.graph.js. This is a library for graph visualization. It supports a variety of graph layout backends, including cola.js, D3 force-directed layouts, and also GraphViz. It's really important for us that this library provides a way to display clusters. And we use GraphViz because it supports clusters and generates high-quality layouts. I will demonstrate the use of CatViz on the adult dataset. Here we have loaded the dataset in R, and you can see the columns in this dataset, including age, work class, education, and so on. Next, we run CatViz prepare, which prepares data structures needed for CatViz visualization, namely the trees, the graphs, and the discretization of the data. Now, I'm going to run CatViz show, which will open up a browser window with the visualization. The main display of CatViz is a graph of relationships between the columns in the dataset. The nodes correspond to the columns, and the edges capture the amount of relationship between them. The choice of the graph can be changed on top. In this case, I'm showing the mutual information graph. You can also see that the nodes in the graph are put in clusters, which can be convenient when you have a very large graph. The clustering parameters can be changed using the menu here. We can filter the nodes or highlight them. We can filter the edges based on the minimum weight. This can be helpful when working with very large graphs. Every node in this graph can be studied further. Let us look at the income variable. By clicking onto the node details, we can get a graph which only contains the immediate neighbors of the income variable. We can filter the edges in this graph using a similar control for cutoff weight. For example, here we kept two nodes that are most highly correlated with income. Next, we can interactively probe the relationships between these variables. To do so, I'm going to display the histograms for these variables. Bar graphs or histograms for these variables will show up in the bottom pane. These three histograms are linked together, so we can explore the relationships between the variables interactively. For example, notice the proportion between people who earn more than 50K to people who earn less than 50K. Let us study how this proportion changes when we subset the dataset to a specific choice of marital status. We do so by clicking on a choice of a marital status. Here I'm gonna choose married civil spouses. And we see that the proportion of people earning more than 50K has increased as compared to before. CatViz allows studying higher order relationships as well. For example, we can click onto income and show the decision tree for it. This decision tree predicts the income variable based on all of the other variables in the dataset. We can hover over the nodes of this tree to see the proportions and the number of rows for each category. We can also look at more details at the bottom here. This can be helpful for people familiar with our part. CatViz provides a number of options, including choices for the layout for the graphs. For example, the dot graph layout is very useful for causal data analysis. Finally, CatViz provides a mechanism for saving the current state of visualization and sharing it with other people.